All right, now at the end of the last video, I told you we'd be practicing something called the factor label method, and I told you that for the most part, I like to call it dimensional analysis, or start with what you're given, put it over 1, and then cancel units left to right, and you'll know what I mean by this in just a second. But let's start with the notes here at the top of page 1, converting quantities from one unit to another. So we're not changing the value, we're just converting from one unit to another. By value, I mean like 12 inches is the same thing as 1 foot, right? We're not changing the value, we're not changing the distance, just the units that we're reporting it in. So I put down a little chart here, and you'll see this chart again. No need to memorize anything. The chart on the chart right now, the boxes that matter are the ones that say conversions. Mass conversions, length conversions, volume conversions. All right, let's do some examples. Write conversion factors for the following unit pairs. Liter and milliliter. Well, 1 liter is 1,000 milliliters. Grams and ounces. 28.3 grams is equal to 1 ounce. So I'm just using the table to get these conversion factors. Liter and quarts, 1 liter is 1.0567 quarts. And if you watch my fingers, I could have written those either way. Okay. Another example, perform the following unit conversions. Now the last example we just did, we were just writing out conversion factors by looking at the table. This is the actual quote, start with what you're given, put it over 1, and move left to right, canceling units. So perform the following unit conversions. The first one, A, 16.0 ounces. We have to convert ounces into grams. I'm more concerned with looking at the units. So for unit conversions, in the bubble there, it says start with what you're given and put it over 1. That's what I'm going to do. 16.0 ounces over 1. That makes me realize in my head visually, oh, ounces is on top. Ounces will have to be on the bottom. And I write the conversion factor, 28.3 grams for every 1 ounce. Cancel the ounces. I'm left with 453 grams. 2,500 milliliters to liters. Start with what you're given, put over 1. 2,500 milliliters over 1 times 1 liter over 1,000 milliliters. My milliliters cancel. Looks like I forgot to cross them off, but milliliters cancel, and I have 2.5 liters. C, 99.0 liters. 99.0 liters over 1. Start with what you're given, put it over 1. For every 1 liter, on the bottom, there is 1.0567 quarts on top. 105 quarts. Okay, now you've just done dimensional analysis 3 times. The number of significant figures I started with, by the way, is the number of significant figures I report my answer in. Next example, convert 0.840 quarts to milliliters. Same type of problem, start with what you're given, put it over 1. 0.840 quarts over 1. I use the table. I got to get rid of quarts, so I put 1.0567 quarts on the bottom for every 1 liter. Now I'm in liters, cancel liters. On the bottom, for every 1,000 milliliters, there's 1 liter. Started with 3 significant figures, 0.840. My answer has 3 sig figs, 795 milliliters. Why is that? Well, conversion factors are, we take them to be exact or true. So 1 liter equals 1,000 milliliters. That is an exact number, kind of like a counting number. So it's infinite sig figs. We start with 3 sig figs in that example. My answer is 3 sig figs. Okay? More examples. This one's a little more difficult, but it's still dimensional analysis. 1 nautical mile, 1 nm for nautical mile, is equal to 6,076.1155 feet. All right, so that is a conversion factor. 1 knot is equal to 1 nautical mile per hour. These are given to us. Here's the question that the problem is asking. What's the speed of a boat? And they want the boat's speed to be in meters per second. What's the speed of a boat going 4.3 knots? All right, well, what are we going to do here? We're given a lot of numbers. 14.3 knots is equal to 14.3 nautical miles per hour. And I figured that out from what was given, where it says 1 knot is the same thing as 1 nm or nautical mile per hour. So I make that my start with what I'm given, but you never want to write a slash in these things because the slash is the horizontal line. So 14.3 nautical miles all over 1 hour on the bottom. Now I can get rid of hours first or nautical miles first. I'm going to get rid of nautical miles and get that into meters. So 6,076.1155 feet for every 1 nautical mile cancels my nautical mile unit. And then for every 3 feet on the bottom, there's 1 yard. I'm out of feet. For every 1.0936 yards, there are 1 meter. And I'm out of yards and into meters. I'm going to stay with meters there. That's why I've circled the unit. It's the one I want. And then I got to get out of hours now, which is all the way on the bottom left. So for every 1 hour on top, there's 60 minutes. Cancels my original hour. I'm in per minutes. For every 1 minute, there's 60 seconds. You do all the math. You multiply all the top ones, divide by all the bottom ones, and you end up with 7.36 meters per second. So if that was too fast for you, back up, write these notes like you're supposed to, practice it, and see that you get the same answer, 7.36. All right, measuring temperature. The measure of how hot or cold an object is. That's what temperature is. Temperature's definition is the measure of how hot or cold an object is. The SI unit for temperature is kelvins, and the degrees Celsius, if you just take whatever degrees Celsius you have and add 273 to it, that's how you get degrees Kelvin. So that box right there is how you go from degrees Celsius to degrees Kelvin. All right, in a second we're going to learn how to go from degrees Fahrenheit to degrees Celsius. Absolute zero, by the way, is 0 Kelvin or negative 273 Celsius. That's the value where molecules in a solid even stop vibrating. So absolute zero, absolute no movement. Now, how do we convert between Fahrenheit and Celsius? At the bottom of the last page, we saw the equation Celsius plus 273 gave us Kelvin, but how do we go from Fahrenheit to Celsius? Well, the equation is degrees Fahrenheit is equal to 9/5 times the degrees Celsius value, and then plus 32. So here's a question. What's 136 degrees Fahrenheit in Celsius? Well, we write down our equation, especially on my types of exams, because you want to write down anything you can to get partial credit. So we then plug in degrees Fahrenheit is 136 equals 9/5 times my unknown degrees Celsius plus 32. 104 equals 9/5 degrees Celsius. So your degrees Celsius, if you do the math, is 57.8 degrees Celsius. All right. Density. Density is equal to the mass of something divided by its volume. So density is mass over volume, and the mass is in grams, and the volume depends on what it is you're talking about. For solids, density is expressed in grams per centimeters cubed. For liquids, we report density in grams per milliliters, and for gases, because gases are so voluminous, they take up so much space, generally speaking, relative to solids and liquids. Solids and liquids are condensed. Gases are not. So we report these guys in grams per liter. All right. Mass percent. Mass percent is the mass of solute divided by the mass of the entire solution times 100%. Okay. Fairly straightforward. If it's mass percent, we're talking about masses. The grams will cancel, and our answer is always in 100%, is in percents. I'm going to do an example problem for you right now, but just to reiterate, solution is the solute and the solvent all together. Okay, don't forget that. So, example, 4.50 grams of CaCl2 is used to make a 10.64 gram solution of calcium chloride. First question says, what's the mass of the solvent, water? Well, we take the mass of the entire solution, 10.64. We subtract the mass of the calcium chloride solute, and what we're left is the mass of the solvent, 6.14 grams, H2O. Now, B is actually totally separate from A, even though it might not look like it. It says calculate the mass percent of calcium chloride in the solution. And they've given us everything we need in the introduction to the problem before A. 4.50 grams of solute divided by the entire solution's mass, 10.64, times 100%, and we are left with 42.3% calcium chloride. So the solution is 10.64 grams, and the calcium chloride is 42.3%. of that mass.